Hey, welcome back to this interview prep series where I'll be preparing for my interview coming up in around 4 weeks. I have a great opportunity that I want to prepare for, and by doing that, I will also, be teaching you guys how to do some of these problems. It's just a way for me to practice personally, explaining the problems and also, informing you guys about how I prepare and, basically how I do these problems. So last episode we did the two sum, add two numbers, and longest substring without repeating characters. That was a fun time. And then I'm going to go ahead and skip number 4. It's a hard problem. We'll come back to that later. Number 5 I did, and number 6 I did by myself, but I'm going to jump into these and explain them to you. So our first one will be the longest palindromic substring. So what is a palindrome? It is a string that is the same forward as it is backwards. So for example, we have BA, BAD. So the substring is any list or any string of characters inside the main string that are a palindrome. So for this example, we have BAB. So forward is BAB, and if you read it backwards, it's also BAB. So that would be a palindrome. This also has another palindrome, ABA. So forwards is ABA, backwards is ABA. But we only return BAB because it is the first palindrome of length 3 that we come across. So there are two types of palindromes that you can see in example 1 and example 2. The first one would be an odd length. So the middle character does not have a pair. It is just a standalone A. And in the second example, we have an even length palindrome, in which case the middle character does have a pair, it's BB. So that is, I guess, something that we can come to see. So I went ahead and wrote down some approaches or some things to keep in mind. And the first one is, of course, we have even length palindromes that we have to account for, where we are matching the current and the current plus 1. And we also have the odd length palindromes, in which we have the current minus 1 and current plus 1 would count as a palindrome. I also made the assumption that a palindrome can be of length 0 or greater. So, if the string is size 0 or 1, I would just return the string because that is guaranteed to be a palindrome. So that is one way of, quickly optimizing this function. And yeah, we're going to go ahead and jump on into it. So like I said before, our first optimization would be an if check. So if s.length is less than or equal to 1, what we want to do is return s. So this accounts for a string of length 0, so an empty string, and a string of length 1. We just return the single character. All right. Let's see. Next up, what do we need to do? We need to keep track of the current longest string. So we'll say let cur sub. We could just call it output. Let output equal. We have an empty string. We could do that. But what I like to do is actually just output the very first character of the string, because we are guaranteed to have, if it passes this check, we know that there's at least one character in there, and we would output that. And then, let's see, there are two ways of solving this problem. There's the brute force method, which would be to have check of B, check of BA, check of BAB, BABA, BABAD. And then from there we check A, AB, ABA, ABAD. Next one we check B, BAD, or BA, BAD. Next one would be A, AD, and then just D. So that would be the brute force method. But what I'm going to do would be sort of more like a 2-pointer, where we have a current pointer, and then, so for example, we have our current pointer here, and then we check, we have two checks. One is for the even length and one is for the odd length. So even length check would just see if the current pointer and the current pointer plus 1 are the same character. In this case, it is not. And then the next one would be a current pointer and then a current pointer minus 1 compared to a current pointer plus 1. So we're comparing this B to this B, and it is a true palindrome. So that would be true. And then if that's true, we would increment and decrement the right and left pointers. So then the next one would be comparing A to out of bounds, and A, it's out of bounds, so it would break out. And we would either update the current output to be this BAB substring if it is longer than length of 1, which it is. It's the length 3, so it would be BAB. And so what we need to do is initialize the pointer. So let pointer equal 0. We'll start at the beginning because there is a possibility that we could have BAB or BBA. So we need to check for the even length palindrome on the first character, even though we already know it is a palindrome itself. So basically we'll do a while loop. So while pointer is less than s dot length. What are we going to do? First up, we need to do a quick check for our even length palindrome. So we'll do a quick check if s at pointer is triple equal to s at pointer plus 1. So that is checking this B here compared to this A. If they're the same, then we would continue on and do our logic. In that case, if that is true, what I want to say is that let our left pointer equal to our furthest left, which would be this current pointer, and let our right pointer equal to the furthest right of the current palindrome, which would be pointer plus 1. And then from there, what we need to do is implement another while loop. I know, it's pretty crazy. So while, so first up we need to do an out of bounds check. So while our left is greater than or equal to 0, and we also need to check our right pointer, make sure it's in bounds. So while right is less than s dot length, and we need to double check that it will continue to be a palindrome. So while s at left is triple equal to s dot right, and then from there, what we want to do is increment outwards. So increment to our right, decrement our left, so we expand one character out each way. And we also need to check if it is larger than the current output. So we need to check if right minus left is greater than the length of this, but we know that an array or any string or any array in JavaScript is 0 indexed. So we need to increment our right first. Additionally, we also know that when we do a substring, it is exclusive. So left to right would actually get the substring between left and right minus 1. So that is another reason why we want to implement this. So if output dot length is less than right minus left, what do we want to do? We want to say that our output is equal to s dot substring, and here we'll go left, right. So this would be our new substring. So our right increments because it is exclusive. So for in this example here, our left would be at 0, and our new right would be at this A here, but it is exclusive. So we don't count this A, we just count the BAB. And then we do that. Very good. All right, so that is our first check. That is for our even pal check. Next up, we have to implement our odd palindrome check. So if our s at pointer, so remember when we're doing our odd, we want to check to the left and to the right of our current pointer. So pointer minus 1, triple equal to, and that's that pointer, not -1, but +1. And then here we say pretty much the same logic, let left equal pointer, but we're getting our furthest left pointer in the found palindrome, so pointer -1. Same thing with our right, our furthest right pointer in the palindrome, so it would be pointer +1. And then we can go ahead and just copy this logic here. And we'll put it here, so while blah, blah, blah. All right, very good. And then we have our 2 if checks. So we check if it is a palindrome, check if it's a palindrome, and then from there, we can go ahead and move forward in our pointer. So here we'll go pointer ++. And then at the end of it, what we want to do is return our output. So let's see, we can walk through this one real quick. So we have BA, BAD. So let's see, our current value at this point would be B. Our pointer would be at 0. Go here is S pointer. So that would be our B equal to pointer +1. Is B equal to A? No, it is not. So we continue on down here. Pointer -1 out of bounds. Is it as out of bounds equal to A? It is not. So we continue and then we just increment our pointer. So our pointer is now at 1. Then we come up again. So pointer is at 1, which would be our A. Here. So is A equal to pointer +1, which would be B. Is A equal to B? It is not. So we'll skip down here. Our pointer is at 1. Is pointer -1, that would be our B here, equal to pointer +1, that would be our B here. That is true. So left pointer would be equal to our 0, and our right pointer would be equal to our 2. All right, so let's see. While left is greater than or equal to 0, that is true, and right is less than string length, which is 5, so 2 is less than 5. And left is equal to right, B is equal to B, correct. We increment our right pointer, so 3. And then we say output.length is less than right minus left, so 3 minus 0, which is good because, you know, again, JavaScript is 0 indexed. So that would be, yes, this is an actual length of 3. Is 3 larger than our current length of just 1? And yes, it is. So we say our output is equal to substring of S from left to right. So from 0 to 3, this one here, we take everything before that 3. So we take BAB and we update it to this. So our new output would be BAB. Of course, this would be a string. And yeah. And then you go through that all the way, increment our pointer. So again, we decrement our left, and then at that point, left is no longer greater than or equal to 0. So we would break, and then increment our pointer, and then go through the same process. So I'm going to go ahead, delete this information here, and then I'm going to go ahead and run a quick test. You know, in my interview, I won't be able to do that, but I'm not in my interview right now, so I'm just going to click around. And what do we get? Do we get anything? Oh, we get it accepted. Perfect. And then I will submit. And then hopefully over here, what does it say? All right, we're better than 75% of people with our runtime. Memory, 35%. That's fine. I always optimize for runtime anyways. That's who I am. All right, so that is our first question. Our next question, this one is a bit tricky, I will say that, but that's only unless you don't know the trick. So the string PayPal is hiring. So I'm going to go ahead and write that here. PayPal is hiring. I don't know if that's true anymore, but that's what they're saying. Let's see. The string PayPal is hiring is written in a zigzag pattern on a given number of rows like this. Okay, so we have 1, 2, 3, and 4. So we have 3 rows, sorry, 3 rows. Then reading line by line. Okay, write the code. So let's go ahead and write out our 3 examples real quick. So we have PayPal, and then we skip 1, 2, 3, A. 1, 2, 3, H. 1, 2, 3, N. And then we start over. We'll increment by 1. So we have A, 1, 2, 3, 4, 1, 2. Sorry, 1, 2, 3, 4. 1, 2, 3, 4. Okay, and then we have Y. 1, 2, 3, I. 1, 2, 3, R. 1, 2, 3. And there's nothing there. All right, so that is our first example. Our second example has 4 rows, it looks like. So number of rows is 4. So we'll go ahead and do that again. So we have pay, 1, 2, 3, 4, 5, I. 1, 2, 3, 4, 5, N, 1. Our next one, we start again, 1 up. So we have A, 1, 2, 3, L, 4, 5. 1, 2, 3, I, 4, 5. Interesting. Are you starting to see a pattern here? Start here. So we skip our first 2. We have Y, 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. And then our last one, we have 1, 2, 3. We have P, 1, 2, 3, 4, 5. I, 1, 2, 3, 4. All right. So what are we doing here? So we have our first line and our last line. Let's look at those first. So in our first line here, the distance between all of these is 6. So we have 1, 2, 3, 4, 5, 6. It is 6 away. And again, 1, 2, 3, 4, 5, 6. It is 6 away. And let's look at our P and our I here. So we have P. So 1, 2, 3, 4, 5, 6. That is 6 away. And then no more. Next up here, we have our A. So we have 1, 2, 3, 4, 5, 6. It is 6 away, this S. But we also have this L, which is only 4 away. And then we have 1, 2, 3, 4, another 4 here, and then 6. So we have 2, we have this S and this G are 6 away, and this L and this I are 4 away from the previous one. Okay, interesting. Are you starting to see a pattern? So we have 1, 2, that is 2 away. 3, 4, 5, 6, also 6 away. 1, 2, 3, 4, 5, 6. All right, let's go ahead and number these rows. So I zero index these rows. So let's see. We have 4. So basically our idea would be that each one is the number of rows 4 minus 1 times 2. That is how we do that there. And then the other ones are also equal to the 4 minus 1 times 2. And what we got to do is also take our row number times 2. So this is 6 So our first one is 6 away, 6 away. This S is 6 away, and this is our first row. So row times 2. So 6 minus 2 is 4 here and here. And then we have our next one. We have this one is 6 away, but this one's 2 away. So row is 2 times 2 is 4. So 6 minus 4 is 2. It's just a quick, simple pattern. It's a bit annoying, but once you understand the pattern, it's pretty, I guess, easy to understand. So basically, I didn't understand this problem until I wrote it out like this. Looking at it like this over here, it kind of makes sense. But when you actually write it out like this or like this, that's when it started to actually make sense for me. Just knowing the distance between each one of these characters or elements in the string. So let's go ahead and write it out. So first, what we want to say is, do a quick check. So if s dot length is less than or equal to 1, we know that we need to return our s. And there's another thing we need to keep account of is maybe there's only one row. So if our num of rows is equal to 1, so that would just be the string itself. All right, so next up, what we got to do is let's go ahead and calculate this one here. So I guess we could call it our incrementer. So that is equal to, let increment equal to, we say, num of rows minus 1, and then we say times 2. So that is our increment between each one of these. And yeah, that's about it. So let's see, how do we go from here? So what we want to do is, let's see, for let I equal 0. Maybe we'll go ahead and call it R. Let R equal 0. R is less than, and what do we want to say? R is less than the number of rows. So my R here represents each row. And we want to increment our R plus plus. And we also need to make sure that we create an output. Let output equal an empty string. So we're just going to add each character onto this empty string. All right, so here we go. We need to do another, I guess, if statement. So let's go ahead and let's say let pointer equal R. We say while, this is a while pointer is less than our, what are we calling it? Our num of rows. Not our num of rows, we just call it our string.length, because we are going to go through our string. So while our pointer is less than our string.length, what we want to do is say that we will output plus equal our s at pointer. And then what we want to do is increment our pointer plus equal our increment. So remember, we move forward with each row as our starting point. And this would get our plus 6s. We also need to account for, the characters that maybe are not the first and the second line. We need to account for this 4 away, and then this 2 away, and this 2 away. So what we need to do is to have another if statement before we add this one here. So if what are we saying? If R is greater than 0 and R is less than num rows minus 1, what are we going to do? So we need to get this character here. So that is equal to output plus equal, and we want to get the increment minus the current row number times 2. So increment minus row, so that was just our R, times 2. And then, yeah, that's pretty cool. And when we do this, we're checking ahead, so we need to also make sure that we are inbound. So, and increment minus R times 2 is less than s dot length. So we need to make sure that we are inbound when we run this. And then we do that, and then let's see. After that, we say, yeah, that's the whole thing. And then down here, what we want to do is return our output. All right, we're running out of time for this 30-minute video. So let's quickly go through this first one here. We have PayPal and number of rows is 4. So the string is longer than 0. No, sorry, the string is greater than 1. Number of rows is not equal to 1. So we do not do this line here. Our increment is equal to number of rows, so that's 3 of 4 minus 1 is 3 times 2. So in this case, it is 6, which is exactly what we want. So we have 1, 2, 3, 4, 5, 6. So this is 6 away from this one. This is 6 away from this one. We initialize an empty output string, and we go ahead and start. So let R equal, we'll start at 0. Pointer's at 0. Pointer is less than length. Okay. R is our pointer. Sorry. Actually, yeah. If R, yeah, our row, we are at row 0. So no, this is not true. We skip down here. Output plus equal s at pointer. So we add RP, and then we increment by 6. So now we are on this I here. Again, we go through it again. R is not greater than 0. Okay, so we skip this part. We plus equal our pointer, so I gets added, and then we increment our pointer, moves ahead to here. Our pointer is still less than the length, so again, it is not, the row is not greater than 0, so we skip down here. We add our in, increment our pointer by 6. It is now greater than s.length. So then we come back up. Row is now 1. So we are now on this A here. Row is greater than 0. Yes, that's true. Row is also less than number of rows minus 1. So yes, it is. And increment minus, so our increment is 6 minus R, 1 times 2 is 2. So 6 minus, oh, that's what we forgot to do. We have to do pointer plus. See, that's why you go through your code. So pointer plus this is less than the length. That is true. So we add our increment minus 2. And that would be this one here, 4 away. And then we add our, oh, oops. We need to do this check after. We'll put that here. See, this is why you have to go through your code before you run it. All right, and then we move on to this one here. Yes, it is less than the length. It is greater than 0. It is less than number of rows. Pointer plus increment is within bounds. So we go ahead and add this one here as well, plus 4. And then we move on to this one. We add it here. We add this one here. This is true. This is true. This one is not true, so we don't do this one here. And then we increment and we are out of bounds. We go ahead and move on. So just based on this code, it should run. I'm going to go ahead and run it. Let's see what it is. Wrong answer. Okay, what is wrong here? Number of rows, 3. Okay. Blah, 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 blah. Oh, you fool. Okay, that's what we didn't do. S at increment. I should have got this. I'm sorry. So, yeah, we know that these numbers are wrong. So we're going to go ahead and add the S at this part here. And let's run it again. Let's see. And we do pass the cases. And I'm going to submit just to check against the larger test suite. All right, so we're in the middle of the pack for runtime, middle of the pack for memory. Slightly better, but that's okay. Yeah, so those are our 2 questions that we covered today. The longest palindromic substring and the ZigZag conversion. I hope I didn't confuse you with the last question. Yeah, I hope you learned something, and I just want to thank you for letting me take this time to practice. Have a great day. If you have any questions, put them below. I'll try and answer them as soon as I can.